All right, in this video, I'm going to be recording the solutions to homework 2.4, which is on derivatives of inverse functions. So the first problem is like a free response type question where you only get the first two parts. Let f be a function with f of 1 equals 0 and f prime of x is given by x times sine of x squared. Suppose g is a differentiable and decreasing function with values given in the table, which you can't see right now, but you can see on your homework. Okay. And the first one says, if it's the case that h of x is equal to f of g of 3x, so it's 3 layers of chain, and we want to know what h prime of 0 equals. Okay. Well, the first step to that is going to be to find h prime of x, right? So h prime of x is going to be, start with the derivative of the outside, f, not inverse, I got ahead of myself. This is not even an inverse function problem. F prime of, leave the inside the same, then multiply by the derivative of the inside. Okay, the derivative of the inside is g prime of 3x multiplied by 3 for the chain rule again, and we've left the inside the same each time. All right. Then h prime of 0 is going to be f prime of g of 0 times g prime of 0 times 3. And then all of the g of 0, f prime of that, and g prime of 0 is all stuff I'm looking up on the table. So g of 0 was 4. So f prime of 4, g prime of 0 is looking like -7, and then times 3. Okay. I just realized f prime of 4 is something I'm going to have to pull out of the using the equation, right? So f prime of 4 is going to be equal to 4 times the sine of 16 radians. Like, great, thanks for that. I don't really know what that is, but so I can conclude that h prime of 0 is equal to -7 times 3 is -21 times 4 is -84, which is also 12 times 7, yeah, that makes sense. And then 84 sine of 16. If you got a calculator, you can figure out what that is as a decimal number, or you could just not. All right, now part B is definitely a derivative of an inverse function, right? If you're talking about a tangent line, we're going to need to take a derivative. But we're also going to need a point. Okay, so what I'm going to tell you is the first ingredient in writing a tangent line is getting a point. So the point will be x equals -1, and y is equal to g inverse of -1. Okay. And, you know, my advice in general is if you're trying to compute g inverse of -1, you go over here and you set up an equation to solve. G of x equals -1. And then you're going into the table and you're looking to find out where does g of x equal -1, and that's x equals 2. And that's me reminding you that g inverse is a function that takes in what you would consider to be y's and gives you back what you would consider to be x's in this course. So I've got x equals 2, so I've got a point -1 and 2. And I probably need to explicitly say that g inverse of -1 is equal to 2, because g inverse is an x value. Okay, we need a slope. And remember that g inverse prime is equal to 1 over g prime of g inverse. Okay, g inverse is that x value. Okay, we already found g inverse, that is 2. Right? So it's going to be 1 over g prime of 2. G prime of 2 is something we can look up in the table. G prime of 2 is looking like -3. So 1 divided by -3. And we're happy. All right, the next one's another inverse function question, derivative. So I want g prime of 3. That's equal to f inverse prime of 3 based on the statement of the question. And I know from my rule that's 1 over f prime of f inverse of 3. Now I'm going to have to do a little work before I'm ready to actually confidently say what that is, but f inverse of 3, that's where I'm going to say f of x equals 3. Here I found it. That's x equals 6. So I can say that f inverse of 3 is equal to 6. Right? Then I'm saying that this is equal to 1 over f prime of 6, right? Because f inverse of 3 was 6. And f prime of 6 is over there. It's negative 2, so that's 1 divided by negative 2. The next one's actually set up a little nicer for us. They're giving us f of x. They're saying h is the inverse function of x. Now, I'm going to tell you, if you're going to try to find an explicit formula for h, that could be potentially difficult to solve for, x in terms of y with the third degree polynomial like that. Doesn't look very easy. I don't know if there's such technique as complete the cube, but I think you better hope there is. I don't think such a thing exists, really. Anyway, we want to know what f inverse's derivative at 3 is, or what h prime of 3 is. So what we need is, remember, that's equal to f inverse prime at 3, which is 1 over f prime of f inverse of 3. But f inverse of 3 is h of 3, right? F inverse of 3 equals h of 3, which is 1. So now I have this is equal to 1 over f prime of 1. Okay, but the thing is, I don't even have f prime yet. It won't be hard to find. I'm just going to go over here to f, drop it down and say, okay, f prime of x is equal to 3x squared, 2x, and 1. Okay. Meaning f prime of 1 is equal to 3 plus 2 plus 1 is looking like 6. And so I can confidently say that this is 1/6. All right, for number 4, when they tell you that f of g of x equals g of f of x is equal to x, I don't remember if I mentioned this in the video, that is code for f and g are inverses. They are each other's inverse. G of negative 2 equals 5, and f prime of 5 equals negative 1/2. G prime of negative 2 equals what? All right, so G prime of negative 2 is like f inverse prime of negative 2. And that's 1 over f prime of f inverse of negative 2. Okay, but f inverse of negative 2 is g of negative 2 is 5. One over f prime of 5. But we actually already know that. That's 1 over negative 1/2. And, if you know that's negative 2, good for you. If you want to stop there, that's cool too. Right? This one looks pretty standard. F is g's inverse, f of 3 equals 8, f prime of 3 equals 9, g of 8 is what? G prime of 8 is what? Okay, well, g of 8 is f inverse of 8, right? Because f and g are inverses of each other. So f inverse of 8 is kind of the solution to f of x equals 8. And that's where x equals 3. So g of 8 equals 3. Okay. G prime of 8 is equal to f's inverse's derivative at x equals 8 equals 1 over f prime of f inverse of 8. Okay, we found that f inverse of 8 was 3. So this is equal to 1 over f prime of 3, which they happen to give us, is 9. And so that's 1/9. Number 6. Oh, I recognize this one. G of x, now let's call it f of x, equals 1 plus 2x plus sine x. G is the inverse function of f. What is the value of g prime of 1? Okay, so the thing about this one is you're not going to be able to calculate an inverse function for f. G prime of 1 equals f inverse's derivative at 1 is equal to 1 over f prime of f inverse of 1. Okay, I think I might have actually done this one as an example in the lesson video, because I always make sure to use this item because this one's a little weird. So just point out, this is a College Board item. So f inverse of 1 is kind of going to be the hard part here. So this is f of x equals 1. And that's where 1 plus 2x plus sine x equals 1. Okay. And they just expect that you could maybe, I don't know, start with that and subtract 1, and 2x plus sine of x equals 0. In general, like, if there's going to be a solution to a difficult equation, it's going to be an obvious solution, like x equals 1, x equals 0, x equals 1, x equals 0, like pretty much one of those two. And you can see that if x equals 0, then that equation is true. So f inverse of 1 is 0, and that's just like a little tricky to figure that out. And that's why I put it on the homework, so that you've seen it before. So this is 1 over f prime of 0. But now this shouldn't be too hard to find, because now my job is to just go over here, take the derivative of f, 0 plus 2 plus cosine x. F prime of 0 is 2 plus the cosine of 0. And so that's 1 over 3. Okay. Right, here's another free response type question, except this is really focused on the derivatives. So, if you watch this far in the video, I'll tell you this is the type of problem that you could expect to see on like a test over this stuff. F double prime of -2. Well, I need to find f double prime of x first, right? So f prime is equal to that. So f double prime of x will be the derivative of f prime. So that'll be pi cosine of pi x, because of the chain rule, plus 2x plus 0. Meaning that f double prime of 2 is going to be pi times cosine of 2 pi plus 2 times 2. And again, if you want to call that 4 plus pi, that's cool. If you want to just leave it there, that's fine too. Right, next, we want an equation for the tangent line to this y equals 1 over f of x at x equals 0. I really liked this because I need to point out to you that this is not f inverse of x, right? This is something completely different. This is f of x taken to the negative first power. And that's part of why the inverse, that -1 power notation is not good, but you need to understand the difference at x equals 0. So y of 0 is going to be equal to 1 over f of 0 equals 1/2. So my point, maybe I'll switch up the color to blue. My point is 0 and 1/2. My slope, that's going to require a derivative taking. Dy dx is going to be equal to the derivative of, I'm going to rewrite this as f of x to the negative first power. So dy dx is negative, leave the inside the same, to the -2 multiplied by the derivative of the inside. Okay. So what I'm going to do is actually plug in the number, x equals 0. So f prime of 0, oh, that's going to be an annoyance. Wait, did that? I took the derivative. Oh, no, I just plug in. Okay, I get it. So f of 0 equals 2. So -2 to the -2 times f prime of x is sine of 0 is 0 plus x squared is 0 plus 3. And again, if you want to do the arithmetic, be my guest. If you want to stop there, that's cool too. And next we've got this f of square root of 3x squared plus 4. That's going to be quite a bit. Okay, so g prime of x. So let me start with the derivative of the outside, leave the inside the same. Then multiply by the derivative of the inside. Well, the thing about this square root is that we're probably better off writing this as the 1/2 power. So remember, 1/2 thing to the -1/2 power times the derivative of that thing, and that's going to be 6. The insides are unchanged. And that's an equation for g prime of x. It's pretty rough, but you know, that's what it is. So g prime of 2 equals f prime of, and I'm actually going to put in 2, so that's 3 times 4 is 12 plus 4 is 16. Square root of that is 4. So f prime of 4 times 1/2 times, well, that's like the same thing, except it's going to be flipped, times 6 times 2 is 12. All right, so I just need to find out what f prime of 4 is. Well, f prime of 4 is sine of 4 pi is 0 plus 4 squared plus 3 is 19. Let's go ahead and fix that. And that's a number that's equivalent to the right answer, right? Okay. And then the last part of this for your response question is h equals f inverse. H prime of 2 is what? So this is f inverse prime of 2. I know the formula. No, that's not how it starts. 1 over f prime of f inverse of 2. Right? I just need to figure out what f inverse of 2 is. F inverse of 2 is, where does f of x equal 2? I found it. X equals 0. So this is equal to 1 over f prime of 0. You plug in 0 for x into, you know, this formula right there, and you're going to see that it's 1 over prime of 0. Sine of 0 is 0 plus 0 squared plus 3 is that. Okay, very doable. They're saying that f equals 2x plus 1 cubed. G is the inverse function of f. F of 0 equals 1. I want g prime of 1. So again, that's equal to f inverse prime of 1, which is 1 over f prime of f inverse of 1. Okay, when we see f inverse of 1, what that really means is, where does f of x equal 1? Equals 1 and x equals 0, right there. So this is equal to 1 over f prime of 0. And I'm going to need to figure out what f prime of 0 is by finding out what f prime of x is. That's going to be 3 times thing to the 2 power times the derivative of that thing. All right, and then, whoops, I need f prime of 0 equals 3 times 1 squared times 2 is equal to 6. So that's equal to 1 divided by 6. All right, I'm going to skip number 9 in the interest of, getting this video recorded and quickly. And I'm going to tell you, if you're having problems with number 9, that's a tough question, and you should come and talk to me about it personally. I'll tell you, it's like, that was the one that I put on there to challenge you, so I'm not going to just give you the answer. But if you want to talk about it, just come and see me. Come in early or during lunch, or just sometime when you have time, and I can talk to you about it. So f and g are differentiable functions with values given in the table at left. All right, g inverse is the inverse function of g. Line tangent to the graph of y equals g inverse of x at x equals 2. Okay, so I'm going to need a point. 2 and g inverse of 2. G inverse of 2 is where g of x equals 2 is equal to 1. So my point is 2, 1. My slope is the derivative of g inverse is 1 over g prime of g inverse. Well, we found that g inverse was 1. So g prime of 1 in the table is looking like 5, so that's 1/5. So I've got a point and a slope. I'm ready to write down my equation. This is only part A, I guess. The equation is going to be y minus 1 is equal to 1/5 of x minus 2. Part B will be, it's a little weird. I wonder if this was going somewhere. Like building up towards a later part that didn't fit within what we were doing. F of g of x minus 6. I'm just going to see why you do that. But anyway, h prime of 2, wait, h of x. So I need h prime of x is going to be f prime of g of x multiplied by g prime of x minus 0. 6 is just 0. So H prime of 2 is going to be F prime of G of 2 times G prime of 2. So I go and I look up the table. G of 2 is 3. Prime of 3 is negative 4. G prime of 2 is equal to 1. That's all I got for you.